Problem 4-24. Solve each of the following equations using any method. Be sure to check your solutions. Problem A. Negative 3 times the square root of the quantity 2x minus 5 plus a 7 equals negative 8. I'm going to solve this algebraically, and then I'm going to check that answer on my calculator. So here we go. First thing, I'm going to take it and I'm going to start out by undoing some of the things that are happening on this side. I want to isolate the square root here. So I'm going to get rid of my 7 and my negative 3. So the first thing I need to get rid of is the 7. I'm going to go ahead and subtract my 7 from each side. So 7 minus 7 is going to give us 0. Negative 8 minus 7, if you really need to, use the calculator. But negative 8 minus 7, we should know is negative 15. That should still equal everything that was left on the other side. So the negative 3 times the square root of 2x minus 5. Let's go ahead and undo the negative 3 times the square root of 2x minus 5. So I'm going to take it here, and how do you undo when you're multiplying something by a negative 3? You have to divide it by a negative 3. Let's divide this side by a negative 3. So negative 3 and a negative 3 there, that's going to be a giant 1. You know, anything divided by itself equals 1. We're left with the square root of 2x minus 5 equals negative 15 divided by negative 3. Well, the negatives are going to cancel each other out, and then 15 divided by 3 is going to give us 5. So we're going to say right now the square root of some number equals 5. Well, what number can you take the square root of it and it equals 5? Think about it here. Square root of something we don't know equals 5. Well, if you think about, oops, I didn't mean to do that. Let's go back over here. Think about the square root of 25 equals 5. That means that whatever we have inside of here has to equal 25. Now there's a couple ways you could do it. You can think about it like that. If this is the square root of 25 equals 5, and the square root of 2x minus 5 equals 5 here, well, we know then that the 2x minus 5 has to equal 25. We can take it and solve that the rest of the way there. Add our 5 to each side, we should have 30 should equal 2 times some number. Well, 2 times what equals 30? Well, x would have to equal 15. Now that's one way of looking at it there. If you are more comfortable with taking and undoing the square root, you could do that too. Just make sure you keep your equation balanced. So the square root of 2x minus 5 squared, it should give us 2x minus 5. And 5 squared is 25. And you see we're at the exact same point now that we were over here. So we know that x should equal 15. Now let's look to check it here. I'm going to bring my calculator in, move it over here. And just like you should have probably done on problem 4-22 and 4-23, I'm going to graph this equation by turning it into two different functions. I'm going to take everything on the left side. I'm going to graph that as part of its own function. And then I'm going to graph everything on the right side. And it's kind of funny because look, the only thing over here is negative 8. But I want you to see that it still works when you do it this way. So let's type in our left side. We have negative 3 times the square root. Remember that's second. And then the x squared button there. We have 2x minus 5. And we're going to add 7 to that. And now I'm going to arrow down here, and I'm going to put in my right side of my equation, which is just negative 8. So negative 8 there. Think about what kind of line would y equals negative 8 create. Let's see if you're right here. Let's go ahead and let's press graph. There is our radical function, and there is our horizontal line where all the y values are -8. Now it looks like they might intersect here, but we're not completely sure. So what we're going to need to do here is we're going to need to expand our window. As our x-axis increases this way here, it looks like our two functions are going to intersect somewhere out here. So let's go into second. Actually, we don't even need to go into second there. Let's go to window. Let's go into window, and we're going to look at increasing the maximum value for our x's. So we're going to go down here, and we're going to say, let's go ahead and make it somewhere. Let's just move it down there. Let's say 30. Let's go back and look at our graph. And now we can see here that there is an intersection point. And remember, we can use the calculate menu to calculate the intersection here. Let's go ahead and do that. Let's put in our, actually let's go in and do our key press history. Let's clear out what we got in there. Remember, if you don't remember the sequence, it's going to be second, trace. We want to find the intersection, so number 5. Mark our first curve there by pressing enter. Mark our second curve there by pressing enter. And then enter one more time, and it's going to tell us that the intersection point is at 15, -8. So if we look back over here, we said that x had to equal 15. Our solution there where x equaled 15. Where does the -8 come into play in the system? Well, remember, if we take our 15 and we plugged it back in to our equation here, what value should it equal? It should end up equaling -8. Let's move on to the second problem here. Second problem we have says 2 times the absolute value of 3x plus 4 minus 10 equals 12. So we're going to take this and solve it algebraically first. So I'm going to go ahead and undo the subtracting 10 by adding 10 to each side. This is not the only way to do this. This is just the way that I choose to do it. Now I have 2 times the absolute value of 3x plus 4 equals 22. This is a great time to use the looking inside method for solving equations. If we look at 2 times the absolute value of something should equal 22, well, what number do you multiply 2 by to get 22? We know that number would have to be 11, so 11 would be a number that would work inside of here, but because we're taking the absolute value of it, we also have a second value that could work inside of here. What other number could you plug in that has an absolute value of 11? That would be -11. That means that whatever we have inside of here, the 3x plus 4, has to equal 11, or it has to equal -11. And you could take it and solve it from there. This would be looking inside over here. So we looked inside, we know this has to be 11 or -11, so we're going to say 3x plus 4 has to equal 11, or 3x plus 4 has to equal -11. Solve each of these. I'm going to say subtract my 4 from each side there. I'm going to end up with 3x should equal, subtract 4 from 11, I should get 7. Divide each side by 3. And I get that x equals 7/3. This one here, I subtract my 4 from each side, I should get 3x should equal -15. Divide each side by 3, and I get x equals -5. So there are 2 solutions that I've come up with here. This was looking inside to get to my answer here. I'm going to show you here how to undo real quick as well. So if we take our 2 times something here equals 22. If I want to undo the fact that I'm multiplying all of this by 2, divide it by 2, but I also have to divide this side by 2. So I get the absolute value of 3x plus 4 equals 11. In which case here, I'm still going to go back and think about looking inside there. So you could take this one more step if you wanted to, or just go ahead and go from here on into this part of it. Now, if we say that x equals 7/3, or x equals -5, you can take it and plug them back in to make sure that they work, or you could graph them to see if they work as well. Let's graph it and see what happens. Let's go over here. Let's do y equals. Let's clear that out. I'm going to type in the left side as one of my equations. Okay, so I'm going to type in this side is going to be one of my functions, I should say, and then this is going to be my other function. So y equals 2 times the absolute value. I'll do this one the other way. If you go into math and you arrow to the right one, it's going to be the top choice there. We have 3x plus 4. And then we have minus 10. My second function there would just be y equals 12. Now I'm going to start out with my standard window here, but I know that it may not fit in there because of what we've got going on here. With our numbers, these numbers are outside of my standard viewing window. My highest point here for y is 10, but over here my equation would have given me y equals 12. So I'm going to, you can either zoom out or you can, actually let's do that, we haven't done that yet. Let's zoom out, let's just do a zoom 3. Sometimes this kind of gives you an idea of where everything is at. So there are our two functions there. You see that it does intersect twice. And if I want to be real clear about it, because I'm zoomed out so far, it's really hard to see, I can go in and do my calculate the intersections one more time. So I've got second trace, got number 5. Let's move it a little bit closer to the left side. That's what I'm looking for first. So enter, enter, enter. I get x equals -5 when y is 12. I think that was one of our solutions there, right? We had x equal -5. And let's do it one more time. Let's do second trace, number 5. This time I'm going to, instead of arrowing over, I'm going to show you that I can just type in a value here. Let's say I type in when x is 4. Oops, didn't work for me that time. Why did it not work? Well, let's just arrow over. Let's just go over this way. Come on over. There we go. We're just a little bit closer. It doesn't have to be right on it. So enter, 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 and we get 2 1/3 when y is 12. Well, 2 1/3, remember, is the same thing as 7/3. Those are the same thing. So we know we are correct there as well. So we've solved this equation algebraically, and we've used our calculator to check it. I encourage you to use your calculator to check your solutions. It's a pretty reliable resource as long as you type things in correctly. If you have questions about doing this or how to do the problems, make sure you ask your teacher. That's what they're there for. Thanks for listening. This is problem 4-24.